10, maximum 16 marks. We'll go through the question and then we'll come back to the mark scheme. A, we have a function f of x equals a third x cubed plus x squared minus 15x plus 17. Find f prime of x. Okay, so we're just going to power rule each individual piece. So we're going to times by the power, bring the power down. Times by the power, bring the power down. Times by the power, oops, bring the power down. And we're left with 0 at the end. Okay, B, let's... the graph of f has horizontal tangents at the points where x equals a and x equals b. A is less than b. Find the value of a and the value of b. So f has horizontal tangents. So that's implying that f prime of x equals 0. 0 therefore equals x squared plus 2x minus 15. Let's factorize if possible. So we have x, 5, and 3. 5, take 3. That tells us that x has values of minus 5 and 3 are solutions. A is less than b, therefore a equals negative 5 and b equals 3. C, okay, as I say, we'll come back to the mark scheme at the end. C, sketch the graph of y equals f of x. Sketch doesn't need to be accurate, but we do need to label some points. We need to mark our x-axis and our y-axis. We know that we have zeros at 3 and negative 5. There must be a line of symmetry at about negative 1, and it passes the y-axis at minus 15, so minus 15. We're going to go as symmetrical as we can. Nice parabolic shape. My 3 is a little bit out, so I'll move that in a second. So let's move that 3. A little bit naughty doing it like this, but you can. Whoop, there we go. Okay, so and then finally label y equals f prime of x. Again, mark scheme shortly. D, hence explain why the graph of f has a local maximum at x equals a. X equals a implies that x equals negative 5. Looking at the graph above, we can see that as f prime of x approaches, we've got a positive gradient. So the values are positive, so it tells us that f has a positive gradient. After this point, we've moved into the negative, okay? So there's a sign change in f prime of x from positive to negative. Oh, okay, let's keep writing the words. Okay, so there's a sign change from positive to negative, which tells us so if we were looking at that on a diagram, we would be positive coming into minus 5, we'd be 0 at minus 5 and negative afterwards, so local max. Okay, we do need to state that it is a local max at that point, but it's because we have a sign change from positive to negative. E, find the second derivative at b. Okay, so the first thing we need to do is, so it's telling us that we're going to look at b is equal to 3. We're going to get continuation or follow through marks at this point if everything's going wrong. F prime of x is, so we had an x squared, that's going to give us 2x. Let's just jump back a little bit. Plus 2x minus 15, so that's just going to be plus 2. Substitute 3 in for our x value now, so we've got 2 times 3 plus 2 is 8, sorry. And that's our final there. Hence, use your answer to part D1. Well, there isn't a D1, so hence I would guess we're using this bit E to show that the graph of f has a local minimum at x equals b. So f prime of 3 is greater than 0. So it's concave up So that implies local minimum. So we could also state that it's greater than 0 and that it's a local minimum because of that value, or that f prime is positive. Okay, many different ways. G. Okay, so I need to just add. So the normal to the graph of f at x equals a and the tangent to the gradient of x at b intersects at the point PQ. All right, I'm just going to sketch what's going on here. So we know what f looks like. We don't know the exact points. I just want to try and visualize what's going on here. So we know that f is going to look something like this. Okay, so y equals f of x. We know at this point that we have -5 and f of -5, and let's go purple. Here we have 3 and f of 3. The tangent at A. So the tangent at A is this. So the normal is going to come, so this is the normal. Then if we have 3, we've got the tangent at 3. So we're looking for the point at which they intersect here. Well, now we look at this. This should tell us they intersect when x equals -5. Okay, so that tells us there that p equals -5. And we also need to find find this value. We need to know what f of 3 is. So f of 3, we're going to substitute this into our f of x. Just need to go back a bit. So x squared, 3x squared, sorry, it's here, isn't it? Minus 15 times 3 plus 17. 3 cubed is 27, divided by 3 is 9, add a 9, minus 45, add 17, 18 add 17 is 35, minus 45 is minus 10. So f of 3 is minus 10, and that now gives us the coordinates. So intersection point is -5, -10. And that tells us that p equals -5 and q equals -10. Right, let's go back to part A, have a look at the mark scheme, see what the marks are. So part A, M1A1 for this, M1A1, just outright straight. B, correct reasoning, f prime of x equals 0, M1. Valid approach to solve quadratic, M1, and then a equals -5, b equals 3 is A1. C, sketch the graph, and we're anticipating that we have those values seen. Yes, we need -5, we need 3. We don't necessarily need this label, but it will be better to see it rather than not, so it should look something like that. It's just going to be an A1. The first derivative changes from positive to negative, so sign changes from positive to negative, so local maximum R1, oh no, it's an A1. E, find the second derivative at 3, so we've got A1 for this first, sorry, let's go here. Where are we going? Here, this one's an A1. F prime of 3, so this is now an M1, and the final answer of that, 10F. Second derivative of FB is positive, so graph is concave up, so local minimum at x equals b, R1. And then finally G. Normal to f at x equals a is x equals -5 seen anywhere. X equals -5, 1. Attempt to find y coordinate at their b values. F of 3 is -10. M1, oh, and A1, M1, A1. Tangent at x equals b has equation y equals 10. Yep. Intersection at 5. Yep, there we go. So that's A1. And then final answer to make sense of the question, A1. Sorted.